Sorting is the process of putting a list in order, either in ascending order, meaning from lowest to highest, or descending order from highest to lowest. MATLAB has a lot of built-in sort functions, and there are many different sort algorithms. One strategy is to leave the original list and create a new list with all of the same values but in sorted order. Another strategy is to sort the original list in place. The selection sort will be used as an example of sorting a vector in ascending order in place. So this is going to be an example of the selection sort. Here's a vector that has 6 elements in it, and what we're going to do is we're going to sort this vector in place. So we start with the first element, and what we want is to get the smallest value in the first element in our vector. So we start by looking at the 85, we look at the 70, we look at the 100, look at 95, look at 80, look at 91, and we find that the 70 is the smallest value. And so we want to put that in the first element of the vector, and the way we can do that is by exchanging the 70 with the 85. So the 70 is up here, and the 85 is down here. Okay, so now we're done with the first element. We've got the 70 in the first element. We're done with that, and now we can look through the rest of the vector. So now what we want is for the second element, we want the second largest value. So in other words, smallest value. So in other words, we want the smallest value from here, the second element, on down. So once again, we start with what's in the second element now, which is the 85. So that's the smallest number we've seen so far, but now we're going to go through the rest of the vector and look at the values to see if there's anything smaller, and we find that the 80 is the smallest value. So once again, we're going to put the 80 in this element, in this case the second element, by exchanging the values. So this is going to be 85, and this is going to be 80. So now we have the two smallest values in the first two elements in the vector, so we're done with the first two elements. We basically don't have to look at these two elements anymore. So now we're on the third element. We have 100 there. So that's the smallest so far, but now we're going to go through and we're going to look and see if there's anything smaller, and we find that the 85 is smaller. So we're going to put the 85 in the third element in the vector by exchanging with the 100. So now we're done with the first three elements. So now we look at the fourth element. 95 is the smallest so far, but now we're going to look through and see which is actually the smaller value. It's actually not important when we find that the 91 is the smallest. The fact that it's 91 doesn't matter so much. What matters is where it is, because I have to know I'm exchanging what's in element 4 with what's in element, and that's what I need to know, is which element it is. So I'm exchanging elements 4 and 6, so now this is going to be 91 and this is going to be 95. Okay, now I'm done with the first four elements, got everything in place there. So now I'm looking at element 5, 100 in there, 95 is smaller, so exchange their values. So we have 95 and 100. So let's write these over here. We have 70 in the first element, we have 80, we have 85, we have 91, we have 95, and 100. So we got the 5 smallest values in the first 5 elements in the vector. Therefore, the sixth element is the largest value. So we've sorted this vector in place. So the algorithm that we just went through is the following. We're going to put the next smallest number in each element in the vector by looping through the elements from the first through the next to the last, and then the last will automatically be the largest value. For each element I, we want to find the index of the smallest value. So we start by saying the top element, where we are now, is the smallest so far. What is needed is to store its index. We loop through the rest of the vector to find the smallest. Again, what we need to know is where that is. And we put the smallest in element I by exchanging the value in element I with the element in which the smallest was found. So again, we need to know where that location is. So here's a selection sort function that implements our algorithm. So we have one input argument, which is our vector. Now what we're going to do is we're going to sort this in place. So we're going to loop through the elements in the vector from 1 to the length of the vector minus 1. Okay, so we're going to get element 1 set up, and then 2, 3, 4, etc. Once we get everything to the next to last set up, then automatically the last is the largest value. We're going to store the index of the lowest value, which right now is I. But now we're going to loop through the rest of the vector. So j is going to go from I plus 1 to the end of the vector. Okay, so we're looping through the rest of the vector, looking to see if there's anything smaller. So if vec sub j is less than vec sub our in low, then that means we found a smaller value. But again, what we need to store is the index, not the value that's stored in that index. So we need to know where it is. And we're going to exchange, once we get through this loop, and we've found this next smallest value, we're going to put it in the element I by exchanging what's in element I with what's in element ind low. So the way we do that is with a temporary location. So we're copying from vec sub I into a temporary location. So let's see, we have our vector. So let me just use this as an example. Let's say we have x and y, and that's what we want to interchange. So we need to copy one of them to a temporary location. So we copy one of them to a temporary location. And then we can copy the other one up here. So this becomes y. That's the second step. And then the third step is to copy from here to here. So we've got y here and x here. So that's the basic idea, exchanging elements. You need some temporary location. So you take one of the elements, store it in temp, and then vec sub in low gets stored in vec sub I, and then the temporary value that you stashed goes in vec sub in low. So this accomplishes sorting the vector in place, and then once we're done, we just assign it to our output argument in order to have the function return the sorted vector. Okay, so how about a vector of structures? So here's an example of a vector called parts. Or rather a data structure called parts. It's a vector that has 4 elements in it. Each element is a structure that has 3 fields for the code, the quantity, and the weight. So if you had a vector of structures, what does it mean to sort it? Based on what? Based on which field? So for example, you could imagine that you might want to sort it based on any of the fields. You might want to sort it alphabetically based on the code field. You might want to sort it numerically based on the quantity field, or you might want to sort it numerically based on the weight field. So the sorting would be done based on the actual field, for example, parts sub I dot code, but you would exchange the entire structure. So you have to keep the integrity together. So code X has a quantity of 11 and a weight of 4.5. So we wouldn't want to just exchange the codes. We would want to exchange the entire structure. So again, if you're sorting a vector of structures, the comparison would be done based on the particular field, for example, parts of I.code, but then when it comes to the part in the algorithm we're exchanging, you're exchanging the entire structure. So you're exchanging entire elements within the vector.